Hello everyone. So let's talk about the second part of DC circuit, the Kirchhoff's rule. So in the previous lecture video, we discussed how to solve programming using equivalent resistance technique. And if you have only one battery, you can always find out the equivalent resistance of resistors connected in a even very complicated series and parallel combinations. However, especially if you have more than one battery, then it's not very easy for us to reduce the circuit to a simple series or connected connection. And for that, we need Kirchhoff's rules. So there are two rules. It says if you have a junction, the current that goes in and the current that goes out of this junction should equal each other. So the total current going through this junction is zero. Now this makes sense, right? So if you have a junction of water pipes, the water goes into this junction and the water goes out, this junction should equal. So if you have a junction, the sum of current into any junction should be zero, and this is consistent with charge conservation. And another rule of Kirchhoff's rule called Kirchhoff's loop rule is that if you have a loop in the circuit and all the sum of a potential difference around the loop should equal to zero. This statement is consistent with energy conservation, which also says electric force is a conservative force. Now, this is a cartoon illustration of how we should understand Kirchhoff's loop rule. So we start from an electron with electric potential 0, then going through a battery, which means battery pump is electric potential to epsilon, and then after it go down a resistor is decreased by IR, and from Ohm's law, we know I times R should equals to this epsilon, so decrease by epsilon goes back to its initial potential. This is loop's rule. For any loop, the potential should add up to 0 along that loop. Now we have to keep in mind the sign convention. So if your loop goes from negative end to the positive end of the battery, then you should have potential increase for battery. If your loop go from positive to negative, you go this way to this way, then your potential decrease for this loop. On the other hand, for a resistor, the loop can in the same direction of the current or in the different direction of the current. If the loop is in the different direction of the current, then along the loop we are going from lower potential to higher potential for the resistor, so you should have positive IR. Your potential increase when you go from here to here. So on the other hand, if your loop is in the same direction of the current, you are going from higher potential of the resistor to the lower potential end of the resistor. Your potential decrease, you should have negative I times R from Ohm's law. Okay, let's do one example. So we have two batteries, two resistors connecting like this. Now we want to find the current going through all the resistors and the current going through the 10-volt battery. I kind of can guess the current going through 30 omega should go in down, current going through 20 omega should go in down too. Then this is I1, this is I2. I should have a junction rule. Current going through here is I1 plus I2. Okay, so figure out what's the current going through each element now. I1 plus I2 split I1 plus I2, and then I want to merge to I1 plus I2 here. I just need to build some loops for me to calculate what's the current going through the 30 ohms and the 20 ohms. So let's build this loop. Let's call it loop 1. This is loop 1. Assume I start from here. So going along the loop, going across the battery to the other side. And so I should write epsilon, right, which is 10 volt from here to here. Now here the current is I1 plus I2, but there's no matrix, no circuit elements, so the potential difference 0. Now it goes down, which is current I1, resistor 30 ohms. So we subtract I1 30 ohms equals 0. Goes back to where it starts. So very quickly I can find out that my I1 should be 10 over 30.33 amperes. Okay, so I need to find my I2 now. So I need to use this loop. I will choose this one loop 2. So this is from loop 1. Loop 2. So I go from here, going along the loop. Current is pointing down. So current here is pointing down. So I should I1 times 30. This is this potential change, right? So I need to know is positive change or negative change. I follow this loop. So from here to here, and in the loop is in the opposite direction of the current. So it should be a potential increase. And the loop goes to this 20 ohms resistor, and loop is in the same direction of I2, same direction of its current, so it is negative potential change. I2 times 20 ohms, and then battery from following the loop from positive of the battery goes to negative of the battery. And I already found out what is I1. I1 times 30 ohms give me 10. Okay. And I can solve my I2. The current going through 20 ohms resistor is 0.25. So the current going through this 10 volt battery, which is total current I1 plus I2, will be 0.58 amperes. Okay. So hopefully this one helps you understand what is Kirchhoff's rules and how to apply Kirchhoff's rule for the problems you have in this class and probably you might going to have in your future classes. And I will see you next time. Thank you for watching.